Most of today's oscilloscopes can perform measurements automatically, without counting divisions and without manually positioning cursors. Let's now perform some measurements automatically and also get an understanding of what some of these measurements mean. Hi, I'm Johnny Hancock, Product Manager for Keysight Technologies and Infinivision oscilloscopes. Now we're getting to the fun part of these oscilloscope lessons. But rather than making some simple automatic measurements on the sine waves from our resistive divider circuit, we're going to use one of the built-in education training signals of this oscilloscope that will show us a wider range of possible parametric measurements besides just volts peak to peak and frequency. Let's get started. So here's a series of digital pulses. You can see that and they're not perfect pulses. You can see there's overshoot and ringing. Let's get a couple cycles on screen and perform some measurements, some automatic measurements on these pulses. So up here, we talked about the measure section of the scope in the previous lesson. Right next to the cursor key, there's a key that says measure. It really means measure. Measure wouldn't fit on the key. If I select measure, the scope automatically turns on two default measurements. It's the most popular measurements, frequency and volts peak to peak. You can see the readings down here. So this is about a 10 kilohertz signal with a peak to peak amplitude of about 3.8 volts. Now let's add some additional measurements. We can do that by pressing this where it says type, and a list of 33 possible parametric voltage as well as timing measurements can be selected. Let's go up here closer to the top and select a couple of them, and I'll explain what they are. Max just measures the absolute maximum or positive peak of the waveform. Min measures the absolute minimum or negative peak of the waveform. Right now I've got 4 measurements on screen. That's the maximum on this scope. All of our higher performance scopes can show many more measurements than this, up to 10 measurements simultaneously. Now we can also turn on statistics for these 4 measurements, and I can see the average, the minimum, the maximum, the standard deviation, as well as the number of measurements that have been accumulated in this statistical set so far. Now if I select additional measurements, the one that I selected the earliest just slides off screen and you get the last 4 measurements. So let's select some additional measurements. Amplitude is different than volts peak to peak. You can see, you probably saw it in the previous ones, every time I select a measurement, it pops up the cursors and shows you where the measurement was performed. Amplitude is the difference between the steady state high level and the steady state low level. Now if I was doing this on a sine wave, it would be exactly the same as peak to peak because there isn't a steady state level. But on a digital pulse like this, it usually is different. There can be overshoot and ringing. And so amplitude is different than peak to peak. Top is the steady state high level. Base is the steady state low level. Now let's scroll down and take a look at some timing measurements. Plus width is just a pulse width measurement. Minus width is the negative pulse width measurement. Duty cycle is a combination of a positive pulse width measurement and a period measurement that the scope does automatically internally. Then it takes the ratio and gives you a percent. So you can see we're measuring about 24% duty cycle for these pulses. Let's do another timing measurement, rise time. Rise time, and let me spread this out so you can see it more clearly. So you can see where it's measuring. It measures from where the signal crosses the 10% level on the rising edge to the 90% level on the rising edge. And that 10% and 90% are based on the steady state low and steady state high, or V base and V top levels. Now you can change those if you want to. The threshold, the measurement threshold level, if you go into settings, select thresholds, I can change the lower threshold level to say 20% and the upper to 80%. And now it's measuring a faster rise time. That's because it's doing over a shorter segment. Some devices are specified 2080. Some digital devices are specified 1090. So you have your choice as to where you have the scope automatically find the threshold. You can also tell it an absolute voltage threshold level. Let's do one more measurement, one more repetitive measurement. Positive pulse count. It's measuring no edges. Now let's get some pulses on screen. Now it's measuring 9. Now it's measuring 99 pulses. This measurement can be very useful if you have a burst of pulses, and it's important to know how many are in that burst. Now one more selection I'm going to show you. What if 4 measurements aren't enough? There's a selection up here at top called Snapshot All. If I select Snapshot All, it gives me 24 measurements on this particular pulse that we're measuring. All the important parameters, but it only does it one time. It's not repetitive. The accuracy of the automatic parametric measurements are a lot more accurate than both the visual division counting method and the cursor measurement method we showed in earlier lessons, especially for measurements like rise time and fall time when the 10% and 90% points need to be determined. The scope does that for you. So that's it for lesson number 6 on automatic measurements. For lesson number 7, we're going to talk about probing again, but this time it will be about some of the specialty probes that you might need, such as high voltage probes and current probes. Remember, we have lots of technical resources on oscilloscopes that you can download at the URL listed on your screen. See you in lesson 7. Go University of Tokyo. Go Ichiko.